Hello students, welcome to JEE NEET Chemistry at JP's Academy and I am Nitin sir. Students, in today's lecture we are going to study a very important reaction which is called as Perkin's reaction. So before we directly jump into the reaction, I want everyone to please like, share and subscribe to the channel and share this video with all your friends. Students, let's understand what is Perkin's reaction and why is this reaction so important for JEE and NEET students. Students, in Perkin's reaction, we have an aromatic aldehyde which when heated with an anhydride containing at least 2 alpha hydrogen, in the presence of its own sodium and potassium salt, it produces an alpha beta unsaturated acid. Students, इसमें we will understand enolate formation and इसका mechanism भी करेंगे students, which is very similar to aldol condensation. So let's students jump into the reaction. So in Perkin's reaction, students, we need an aromatic aldehyde. I will mention this point ahead, but remember Perkin's reaction, students, is given only by aromatic aldehydes. So we have Benzaldehyde and हमारे पास we need an anhydride containing at least 2 alpha hydrogens. So let's say students, we have over here acetic anhydride. Now I hope students सबको पता है what exactly is an anhydride. So यहाँ पे है मेरे पास ethanoic और acetic anhydride. We get ethanoic or acetic anhydride from ethanoic acid and we need उसी का salt, a sodium or potassium salt. And when it is heated, students, यहाँ पे ऐसा condensation takes place and हमें दो product मिलता है. The first product is an alpha beta unsaturated acid. Now students, in this reaction, the alpha beta unsaturated acid that we have got is called as cinnamic acid. And the second product that we get, students, is what happens here is condensation. हम इसका mechanism भी करेंगे to really understand how the reaction takes place. Chalo. So this was the reaction. Now let's student understand how the mechanism or how the reaction takes place. Enolate formation क्या होता है यहाँ पे? So let's start with the mechanism of the reaction. Students, now in the mechanism of the reaction, the sodium acetate that we have, वो acetate ion जो हमारा base है, the base will extract a proton from the anhydride that I have. So ये very similar to aldol condensation students mechanism. तो ये जो आपका base है, the base extracts a proton. And यही है students हमारा enolate ion formation जो हम कह रहे थे, and this results in the formation of the enolate ion. Now students, this enolate ion and हमारे पास benzaldehyde है, and students during resonance the carbon will get a positive charge, the carbonyl oxygen gets a negative charge. This is our the enolate ion. ये हमने next. So what happens here, students? We have the carbonyl carbon is bonded to over here the enolate ion that we see over here. यहाँ पे आप बोल सकते हैं ये वो अल्फा कार्बन को ज्वाइन कर रहा है. Next solvent होगा solution में. So we are going to now protonate the carbonyl oxygen with the help of the solvent which is present in the solution. So what do we get here, students? And then students, इसके बाद the only step which will be left will be the condensation part. On heating, this is how the condensation will also take place. These electrons here will be used to form the double bond. And then finally one more step and we will get our product. The mechanism is very simple and very quick, students. Finally last step में with hydrolysis, यहाँ पे आप देख सकते हैं H over here and OH over here, and हमें हमारा final product, students, मिल गया, which is cinnamic acid. And ethanoic acid. Students, so this is the entire mechanism of Perkin's reaction. One more thing, students, I wanted to say that if you want to increase the reactivity, the presence of an electron withdrawing group, I repeat, students, the presence of an electron withdrawing group increases the reactivity, electron withdrawing group, on the aromatic aldehyde, increases the reactivity. Why, students? Let's understand this. And this is also true if you really consider this for aldol condensation, because students, when you have an electron withdrawing group at the para position, specifically what happens is the electrophilicity of the carbonyl carbon increases. ये जो हमारा carbonyl carbon है, students, ये carbon पे जो positive charge, the electrophilicity of the carbonyl carbon will increase because of the presence of an electron withdrawing group. Second, students, हमें एक second point क्या ध्यान में रखना है यहाँ पे, that Perkin's reaction is given only by aromatic aldehyde. Perkin's reaction is given only by aromatic aldehydes. And one more point, students, sometimes triethylamine is used as a base which increases the yield of the reaction. I repeat, students, triethylamine is used as a base which increases the yield of the reaction. So students, these were all the important points of Perkin's reaction. Chota sa mechanism. Students, we also have an intramolecular Perkin's reaction and a reverse Perkin's reaction. And students, if you want me to make separate lectures on intramolecular Perkin's reaction and reverse Perkin's reaction, so please let me know. If you liked the video, If you understood the concept, I want you to please like the video, please subscribe to the channel, and share this video with all your friends who are preparing for NEET, JEE and other competitive entrance exams, and who are preparing for the chapter aldehydes and ketones, a very, very important concept. Thank you, students. Thank you so much.